Okay, welcome back again. What I want to do is to continue to look at the electrical principles in regards to Sitting Gills Electrotechnical Technology Level 2. Okay. Now again, you don't need me to talk a lot on this overall. Okay. Now here we have described application of the basic unit used in electrotechnical technology. Session 2, Basic Mechanics. Now, to be able to describe the basic terms used in mechanics, to be able to simple calculations of force and weight. Okay. Okay. Now, review of the application of the basic units used in electrotechnology. Now again, this is just showing you what we've learned so far in session 1, okay? So I'm not going to go through that with you. You can go through that for yourselves. Let's just make sure it's visible and clear, okay? Now here we have standard unit of mass, okay? The SI symbol for mass is M and the unit is a kilogram, kg, okay? When we describe how heavy something is, we usually incorrectly use the term weight when we really mean mass. So your weight, if you're 14 stones, you would have a mass of 14 stones, okay? Mass is usually defined as the quantity of matter in a body. Now remember, there's an understanding that you can move matter, but you can't destroy it. You can only reshape it or convert it to something else. But again, don't hold me to that. Please do your own research just to confirm that for yourselves. Okay? Now force. Let me just go back a little bit, make sure we can get this all in. Okay. Force. Now, force is generally measured by its effect. If I push an object from one place to another, I have applied a force. If I stretch or squeeze an object, I am also applying a force. Okay, so here you have forces being exerted, so I'm squeezing it. Okay, here I'm stretching it apart, pulling it apart, basically. Okay, so any force you exert on an object causes that object to change shape. Okay, good. Now force. Force F involves two quantities, its mass m and acceleration a, or the rate at which it moves. If we want to find out the force of something, we need to use an equation using letters to simplify the idea. Force equals mass times acceleration. Therefore, your formula is F equals m times a, where F equals force in newtons, m equals mass in kilograms, and a equals acceleration in meters per second squared. Now it is important to remember formulas such as F equals m times a. This formula, you will always need it, okay? and it will come up in your exams wherever as a question in one form or another. You may even need to transpose it to find M, or transpose to find A. So be aware of that. So get used to having access to understanding the transposition of these formulas. Okay, weight. Now weight is related to force and mass. It can be defined as the gravitational force exerted on a body by the Earth. So you have a gravitational force of 9.81 meters per second exerted on your body. This means that an object on Earth has a different gravitation force applied to them than other planets. Someone standing on the moon weighs less than someone standing on Earth. This may not seem very important until you want to work out the effort needed to lift something. Okay? And you can imagine trying to lift a rocket into space, the force you will need to get away from the Earth's gravitational force. Okay? This effect is a force weight. This effect is a force weight, etc. The equation for this is very similar to that which describes force, but instead of acceleration A, we now have acceleration due to gravity. So your symbol here now is going to change from A to G. Instead of acceleration, we now have a gravitational force, and that is represented by G. F equals m times G. So with F equals 40 newtons, m equals mass in kilograms, G equals the acceleration due to gravity. Okay, so the acceleration force we know to be meters per second is usually accepted as being 9.81 meters per second. So any calculation involving lifting or dropping an object will use this quantity. So which will drop first? If I drop a hammer and a feather from a 7-story building, which will drop first? I'll leave you to figure that one out. And here we have quantities, okay? There are two types of quantities, scalar and vector. Scalar quantity has magnitude only. Time, mass, and speed have size, but not direction. Let's repeat that again. Scalar quantity has magnitude only. Time, mass, and speed have size, but no direction. Vector quantity has magnitude and direction, force, weight, and velocity. Okay. Okay, I will stop there now for now. Thank you, and I hope you have found that useful. Okay, have a good day. Bye-bye for now. Thank you.